Hello student, today we start our next unit. It's a geometric modeling. In the geometric modeling, we have to study about the geometric representation of various types of curve. First, representation of curve. In representation of curve, there are the two types of mainly curve are divided into two types. First one is non-parametric curve and second one is parametric curve. Okay, in non-parametric curve means it's a representation as a relationship between x, y and z. Means in that curve, if you represent that curve, it is the relationship between means a function of x, function of y or function of z with inter collaboration with each other xy yz xyz. This types of means representation as a relationship between x y and z. It's called as non-parametric curve. In non-parametric curve, again divided into two types: explicit non-parametric curve and implicit non-parametric curve. Okay, in explicit non-parametric curve, it is a y is equal to f of x or z is equal to g of x. Means y is a function of x or z is a function of x under the g. Okay, but in implicit it is a function of x, y and z is equal to 0. Means in implicit curve there is a function must be equal to 0, but in explicit curve function is not to be 0. Then next part of is a parametric curve. Parametric curve is it as a independence parameter. Means it is a function of independent parameters such as a u or theta. Means it not depends on x, y and z, or it not be relationship between x, y, z. It is a directly depends on external independent variable. It's a u or it's a theta. It's a parametric curve. Okay, next, limitation of non-parametric curve. Due to the one-to-one relationship between coordinates x, y, z of the points, the explicit non-parametric representation cannot be used for the representation of closed curve. Means if it is a closed curve, circle, ellipse, parabola, if it is a closed curve, then it should not be represented by the relationship between x, y, z. That's why it not represented by the non-parametric curve. The straight line, if it is a vertical or nearer to vertical, is slope m is infinity or very large value. Such value is difficult to handle in non-parametric curve. Okay. In implicit non-parametric curve, representation of curve required to solving of simultaneous equation, which is a highly inconvenience or lengthy. Means if you have to solve the equation of implicit representation, we have to solve the simultaneous equation, then it is a inconvenient or it is a lengthy in nature. That's why non-parametric curve also not used for the simultaneous equation. In non-parametric curve representation, the equation of curve depends on the coordinate system used. Means if you have to use the user coordinate system, the non-parametric curve representation used as a user coordinate system. But many cases in CAD application, you have to use the user coordinate system, but the you want to relationship between the software coordinate system or screen coordinate system. You want to relationship between the software coordinate system or world coordinate system or a screen coordinate system with the user coordinate system. But in non-parametric curve, they not be make a relationship between your world coordinate system or user coordinate system. Okay, these are the limitation of non-parametric curve. Parametric representation of curve. Parametric is overcome all limitation of non-parametric curve. Means in parametric curve, it is a representation of u and theta, u or theta. It's a overcome all limitation of non-parametric curve. In this, each point of curve is expressed not as a relationship between x, y and z, but it is a function of independent parameter u, and parameter u act as a local coordinate for the points of the curve. Means In the parametric curve, if it is a function of independent parameter u, the parameter u act it is act as a local coordinate system for the curve. If it is a use in user coordinate system, then also it is a act as a local coordinate system for that point or for that the point of the curve. That's why parametric representation of curve is very useful in CAD application. Next, parametric representation of curve. It is a 2D curve or 3D curve. If it is a 2D curve, then function of p is a function of u. It depends on x dash of u, y dash of u depends raised to t. U must be variation between of u variation is between u minimum and u max. Same as in 3D, it's a representation of x, y and z. In that also, u must be u minimum to u maximum. It is a in between u minimum to u maximum. Okay. Next, advantages of parametric representation of curve. It can be easily used for the representation of closed curve. It can be easily used for the representation of closed curve. It replaced slope by the tangent vector. In non-parametric curve, slope is infinity or slope is very high. Then representation is not done. But in parametric curve, representation of slope is replaced by the tangent vector. That's why parametric curve also representation of vertical line also. Okay. For curve such as conic, cubic, the parametric representation use the polynomial. Polynomial function is used for conic or cubic curve in parametric. This is a very good advantages of parametric curve. Then it's suitable for partial curve. Means if it's a half circle, if it is a half parabola, then also parametric representation of curve is useful. That's why parametric representation of curve is very useful in CAD application. Then type of parametric representation of curve. There are the two types, analytical curve and synthetic curve. Analytical curves are points, line, arc, circle, chamfers, conics. Okay, and in synthetic curve included the spline, means cubic spline, B spline, beta spline, or Blazer curve. In analytical representation, point, line, arc, circle, these types of curve are under the analytical curve. And in synthetic curve, it is a spline or Blazer curve. Okay, these are the two types of parametric representation of curve. Okay, what is the next? In next lecture, we have to study about the analytical curve, line, circle, circular arc, ellipse, parabola, and hyperbola. These analytical curve, we go through the one by one mathematical representation of each curve and problems solving of each curve. Okay, in next lecture, we have to study about the analytical curve, line, circle, circular arc, these types of curve. You can study one by one, then mathematical representation of all this curve, and then problem solving of all this curve. Okay, thank you for watching.